Hello, everyone. Thank you and welcome to the Water Tower Research Fireside Chat Series. My name's Graham Madison. I'm one of the analysts here in our Sustainability and Industrial practice. As a reminder, this call is open to everyone, as is all of Water Tower Research is free to everyone. Please go to our website to sign up, watertowerresearch.com. We will be taking questions from the audience, and those can be submitted via the webcast. Hopefully, we'll have time to get to all of them, but if not, our apologies. Just a quick disclaimer, the views expressed in this fireside chat may not necessarily reflect the views of Water Tower Research and are provided for informational purposes only. This fireside chat may be distributed or reproduced without the written consent of Water Tower Research and should not be considered research or nor a recommendation. WTR is an investor relations firm, not a licensed broker-dealer, market maker, investment bank, underwriter, or investment advisor. Additional disclaimers can be found at watertowerresearch.com. So with that, Dip, thank you for joining us. Welcome back to the show. We're happy to have you with you. For everyone on the podcast, Dip is the Chief Technology Officer of Soluna Computing, the operating subsidiary of Soluna Holdings. Quick background, he's been the CTO since 2008, having previously founded and sold a company called Ecovent Systems, doing climate control. Earlier in his career, he worked at Lockheed Martin, focusing on the ballistic missile defense program and advanced radar and electronic warfare systems. He is also an entrepreneur in residence and a lecturer at the Massachusetts Institute of Technology. So with that, Dip, welcome back. A lot's happened since we last had you on the podcast back in February. A lot of projects moving around, and then some pretty dramatic weather this summer. From your seat, how has Soluna's technology handled everything?
Oh, I can't be more pleased, right? So Project Sophie, our project in Texas, has switched over to hosting, right? And we brought Project Dorothy live. And I would say that one of the biggest, like from my viewpoint of bringing Dorothy live is it's much more complicated than Sophie, and there was no ramp up time, meaning we had to kind of be working from day one. And I was just blown away by our team's ability to architect and deploy Maestro in such a way that it was simple enough that we could deploy it and like edit it and work on it, but complicated enough that it allowed us to change the things that needed to be changed once you bring the building live, because things pop up when you bring buildings live. And we were able to do it, and I'm just really excited about it. And you mentioned the weather. Yeah, there was unprecedented weather, and it was absolutely amazing how well our data centers handled it down in Texas. We achieved, record-breaking 1.01 PUE down there, even with the unbelievable heat. So I think the tech worked really well. And it's fun to watch our code come alive and do the things that it was supposed to do.
Great. You mentioned the Maestro operating system. Can you expand a little bit more on that in terms of, from a sort of high level, what does it do, how does it work, and why it's important?
Yeah, I'd love to. Basically what it is it's our software operating system that controls all of the MDCs. It enables all of these things that we talk about to enable the curtailment for the grid, control the computers in a balanced way, run the fans, all of that. Ultimately, it does three major things, right? It controls, meaning it watches all of the equipment on the site and it turns it on and off in a way that's safe. It does it with multiple redundancies, so if anything goes wrong, the site turns off. It doesn't cause problems for the grid. We have got these simulators online that allow us to simulate everything. So there's all of this code that enables the control of the site, turning it effectively into a fully automated building, right? With all these diagnostics. On that note, it allows the operations team to get dashboards, access to this information. So when things happen, they can see exactly how the body is sick, right? Think of it like doctors. Doctors are way more effective with an X-ray and with blood tests, right? It's the same here. The more instrumented we are and the more data we provide to the operations team that's relevant to what they're doing, the more efficient they become. And that's what Maestro does, right? It real-time tracks all these issues, provides diagnostic information, and it pinpoints where problems exist exactly in the data center. So it really just enables our operators to do their job, which is bring the magic brain power, not the automated stuff, right? And then lastly, it allows our site to turn on its power on and off, right? Which doing that with thousands of computers and all of this networking equipment in such a way that can turn on and off in a clean way for the grid, but also in a safe way for the computers and for the customers using that compute is not, you know, as trivial as just turning a light switch on and off, right? We want to make it that trivial, but there's a lot of things behind the scenes. And Maestro like enables us to achieve 99% curtailment in less than a minute, and then get the full power off, you know, minutes after that. And then on the flip side, same thing. And so that's what Maestro does. And I'm just so excited to see it cranking at 2 different sites with 2 very different kind of curtailment algorithms, right? Sophie uses a schedule base that we work with the utility and determine when we should turn on and off. Texas is much more real time, looking at grid stimulus and a bunch of different signals and figuring out what you should be doing.
So this, in case you're working with the wind farm developer or the owner, as well as the grid, like plugging in just whatever comes your way, you're able to react to it that quickly?
Oh, yeah. I mean, we have to work with the grid, the wind farm, as well as the co-ops. The grid in Texas is not just like one entity, ERCOT, right? There's co-ops and there's different players in play. Like you said, the investors, the people who own the wind farm. So each constituency kind of has different risks when you're doing something like this in mind. And, you know, Maestro helps them see that the technology is capable of it. And it all works as advertised, and that makes them very comfortable in allowing us to bring a load like this, right? Because in many ways, Dorothy was the first one to do something like this.
And ramping up and down so quickly. And with
Yeah,
the
and working with a wind farm, you know, directly, and like a lot of those types of things are things that we had to work with the wind farm to do, right? Which is why our algorithm needed to be adaptable, because we were inventing a lot of things as we were coming up with how to do it.
Interesting. On a recent Fireside chat we did with CEO John, he talked about how potential investors were looking at the data centers and also Maestro. Can you talk about what you're hearing from them? And you were probably working with some of their tech people as well, and the interactions you had.
Yeah, I'm smiling because it's finally, now we get to show them the thing working, right? It's always been hey, look what we're gonna build, right?
Yeah, our
So the
simulations,
reason,
which anyone can do,
yeah,
but like
yeah,
now
just
you're
trust us,
like, and
right?
you went
Yeah,
through the with those heat swings, like if you can get through that, you should be able to
absolutely.
deal with a regular day in the fall.
And not only did we get through it, but we were able to show the performance, what happens during those heat swings, right? Our computers adapted, our control system adapted. So that's really what made them, what the common theme with a lot of the diligence teams and the customers that come through to look at our software and look at the system that we've built, not just the code, but the whole data center architecture, is Maestro makes complex things look very simple. It's like our cell phones, right? We don't really understand all the chips in there, but we know how to use it. Kind of the same thing. They look at Maestro and they say that it's reminiscent of software that they've seen at much larger enterprises, right? And so it brings them a lot of comfort, because they come in and they see, oh, wow, yeah, I get it. I see what's happening. And can I click that and control that? Oh, yeah, I can. That makes sense. So they see all of this and they get really excited. And then they see the computers react to what's happening. And when they see it all work as advertised and that we can explain it in a simple way, they get really fired up about it. And we do too, right? Because it's solving a very real problem for the world, for green energy.
And one of the things that's interesting with it was in the news a lot with the demand response or the capacity payments that some of the grids were paying, where you're trying to take off, not saying it right, where you're trying to take off load off the grid to help the grid support during times of really high demand. And there was an article in I think CNBC talking about data capacity payments and other things like that. How does um, as those, I mean, how is Soluna designed for that, where that flexibility, being able to get to the demand when they need the demand curtailment?
Well, that's that's the magic of this, right? It started with thermostats for homeowners, right? They'll say, "Hey, we'll give you a discount if you turn it off during peak hours, or peak load on your dishwasher, and you know, uh, peak hour pricing." These are programs that utilities put in place to help manage the demand from the user side, right? So they could better forecast what they could supply. Well,
And
now
it's
what the grid is
cheaper than
saying is
turning on another power plant.
way cheaper, right? And everybody wins. It's like, why do you want to run your oven at the peak of the day, right? Run it at night, heat your house with it, like, start cooking at a different hour. That was me because I was goofy, but you get the point, right? You could cook
Yeah.
80% of your food in midnight and then finish it during the day, right? For example. So grid operators are thinking this way. It started with demand response, which is very visceral for us, but for the industrials, there's all kinds of programs in place, right? And in ERCOT, they call them ancillary services. These are programs they put in place, usually for utility grade, but people can take advantage of them too, to basically turn on and off their data center under certain circumstances. And if they apply for these things, they can kind of just get these credits. And so the way I'd say it is, this is a fact. Every single grid operator in the world that's trying to integrate green energy with an unstable demand source, people are going to find ways to try and stabilize both sides, right? On this side, we've got batteries, data centers, like we're saying, right, to stabilize supply. On this side, you have demand response programs or ancillary services to handle the demand side, which is what we're saying as well. And so Maestro is designed to do both, right? It's designed to watch the grid and stabilize based on what the grid needs and what the grid's doing. But it's also designed to say, hey, grid, do you need other times for us to be off that maybe aren't these stimulus, that's some other stimulus? Maestro doesn't care. It's going to take in these data streams. The logic is going to consume it and say, I should be on, I should be off, or I should be at this intermediate value. And it'll do what it's supposed to do. And it was architected with that in mind from the get-go, not just the software, but the buildings, the control systems, the power systems, the fans, like, the mindset of the team that's building it. Literally everything has been designed from that in mind, because we see that's where AI is going, right? Like, yes, Bitcoin is the number one use case right now, but if you look at what's happening in the world of compute, generative AI is going nuts, and that is a very batchable load. And it belongs in our data centers, right? Not in typical data centers.
Makes sense. So earlier this summer on the call with John, he was mentioning the Project Kati that you guys were selected, I think, out of 20 or 25 different players there. How did Maestro fit into that? And tell us about from the tech seat of how they looked at you guys and why they chose you.
Well, I'm giggling again, and I'm blushing. It's just because it's fun to hear customers speak kindly of your baby, right? And so, or clients or partners, whatever. And so when what happened is when people visited the site and they see how it all works, how all these pieces come together, they realize that it's not just project finance and structuring, which is also very complicated, but it's also this very, very kind of amorphous tech stack that you have to build, right? That kind of connects to the grid in the way that makes sense for this constituency, this group of people, and these sets of circumstances. And it works with high degrees of reliability, which comes from our DNA in the defense industry, right? So again, it's all baked into the way the company was built. And so we had built it, we kind of got it. Maestro helps communicate it. And they like how we kind of built it in a way that it integrates directly with the power plant. They understood kind of how we do it. And so what they saw is kind of an end-to-end solution, right? And they're like, whoa, this is what we need, not just a transaction, but a partner that understands that there's a lot of complexities here, but they got it. They know how to do it. And that's ultimately why Project Kati, we were able to win it, because we really wanted the project. The wind farm is dealing with curtailment, right? And so, it's important that they're bidding it, fine, at least somebody's going to get it, but we knew it had to be us if we were going to get it done fast, because we know how to do it. We've already done it.
And
There'll
you've
be new
already
things,
been,
of course, as CTO. I know that as engineer, but we've slayed a lot of big dragons, I would say. So
yeah, when you've already been through the ERCOT approval with Project Dorothy, which was extensive. But at least you've got that.
Not as easy as radar, I would say.
Whatever you're dealing with, any government agency, it's that's its own animal. Um, so just to remind everyone in the audience, if you do have questions, please submit them in. One that we have is, Dip, as you look at future projects, what are some of the investments that you want to make on the technical roadmap?
Great question. So again, the main, as you've probably heard from us many times, we have a multi-phase business, right? Phase one, phase two. Phase one is get integrated, show that we can consume the energy, curtail the power. A lot of technical things that were considered, pipe dreams 5, 6 years ago are now real. And Bitcoin is the engine behind that, right? And so right now we're managing one kind of compute in our data centers, but tomorrow we may have multiple kinds of compute, and that's our game plan. It's to evolve the stack, the buildings, and everything as needed. Now, remember, they were designed from the ground up for this dual phased approach, but you still have to make changes as you learn. And so and we haven't built certain technology because it's a phased approach, right? And so now we build that technology and we start enabling it, and it's super exciting because the world is growing. They need it, right? Compute per human is going through the roof, so we better serve it.
And it's only going to get bigger. And I mean, I think that's one of the things you're reading about. I mean, there's an article in the Wall Street Journal about AI today. Just the power demand for it, the computing demand for it. It's
Don't forget the water. Don't
the
forget the
water.
water. It's insane how much water AI uses. Absolutely ridiculous. There was a professor who published a paper, and he said that a 50 to 150 word prompt in Chat GPT to generate the answer consumes 16 ounces of clean drinking water.
Wow. And is that, I mean, well, that's one of the things with your data set, the modular data centers, is that they don't use water for cooling, liquid cooling. So is that looking at?
Well, there are ways to use water for liquid cooling, but you need closed loop, right? You need to not evaporate it. And typically data centers evaporate water to remove heat because it's not calculated in PUE calculations, right? So you get away with it a little bit. And so it's really not it's I don't like it. It keeps me up at night how much water data centers use. And so ours don't use any. That's another reason why I'm really pumped, because we don't need any water to cool our computers.
Well, that's one of the next questions that, we're looking at the modular data centers that, and you talked about PUE, the efficiency. So as one, can you just talk about that and how the industry measures the efficiency for those? But then talk about how your data centers are different from the other ones. And then throw another question in there, maybe talk a little bit about how the design has evolved as you've gone through your multiple iterations.
Yeah, sure. I mean, the core design has been really great. I mean, we deployed it at Sophie, and it performed exactly what our model said it would, a PUE of 1.02 at this stage. And
PUE, just for can you talk about what that, give the listeners some background about how that all.
Yeah, I'm sorry. I use this jargon sometimes.
That's
PUE is, it's nature of the beast. PUE is a measure of how much energy enters a computer versus how much energy enters the site, right? So think of it like this way. If 100 watts comes into the site and 100 watts gets to your computer, you have a PUE of 1.0. It's perfect. There's no loss, right? Our sites, when you measure the power coming into the site, you measure 101 watts. When you sum up the power going to the computers, you get 100 watts. So you have a 1.01 PUE. In Kentucky, it's 1.02 PUE. So 102, for every 102 watts that enters the site, 100 watts gets to our computers. So they perform exceptionally well, but we do always iterate. It's silly not to evolve, as you continue to build buildings. And so one iteration, for example, is we added 2 fans per building, these large fans that are on the back of our building. We added 2 of them for each building in Texas. So we went from 6 in Project Sophie in Kentucky to 8 in Project Dorothy in Texas, and we'll have 8 at Kati as well. And that again brought the PUE down from 1.02 to 1.01, which is, believe it or not, that's a lot when you're dealing with that kind of, there's only so much fat at that point you could trim, kind of like hair in my head. There's not that much left. And so, so that's one thing. The other thing is we just move air efficiently, right? There's not a lot of bends. We have a lot of surface area for our filters. And then our buildings are set up in a configuration that enables the air to not get recirculated back into the buildings. There's a lot of design, and there'll be patents that come out that talk about those things. Basically, that enables us to keep our data centers ultra efficient. Does that mean we won't use closed loop cooling in the future? No, not necessarily, but I'm not sure any of the compute needs it. Bitcoin miners certainly don't. And so that's kind of how we do it. And we built everything modular. So if we need to put in closed loop cooling to bring the temperature, the air temperature down for what's going into the servers, we can do that as well. And that's, again, things that we thought about from the very beginning. If you look at our data centers from the very beginning, even though our phase one was Bitcoin mining, we didn't use containers, right? We use large fans. We use huge amounts of filtration, massive buildings, right? Spread them out in certain ways. All of that was designed with efficiency in mind.
How much has it changed when, in terms of geographic location? Does that make a difference, or you're going to get to the same heat levels internally or
No,
externally?
a lot's changed, right? Because wind directions change, so the orientation of the buildings change. The wind speed, excuse me, the wind speeds change. Now, wind speeds matter because that helps the air recirculate. At a certain speed of air, the air will recirculate. So you have to model all of that. Solar loading changes, heat temperature, humidities change. So all of that determines kind of like the spacing of the buildings, the amount of fans we might need, the PUE we might expect, and ultimately the cooling solution we'll put in place. But again, everything's kind of designed with this modular plug and play method in mind, so we can kind of pull out things and put them in ways that enable us to quickly adapt to the local environment if needed.
And if you need to make an upgrade, it's a simple thing to do. You don't have to rip it down to the ground and bring it back up.
Exactly, right? And what's awesome is these buildings are simple. So they're built, mostly built in a factory and then assembled on site, which allows us to use local people to put them together and construct it, right? Again, like it's always great to work with the folks who live in the communities where we're building these things.
All right, so we're coming up on time, so I've got time for one last question, which comes in from your seat. Have you seen any changes in the way that wind farm operators or the IPPs or grid operators are viewing data centers as a whole?
Yeah, I am. And I'm really pumped about it, right? So if you think about it, a few years ago, 10 years ago, 20, maybe 15, when wind farm operators were looking at wind farms, they weren't considering batteries, right? 5 years ago, 10 years ago, they started adding batteries into the mix to increase the size of the wind farm, to increase the bankability of these wind farms, right? The profitability. Well, now they're starting to look at data centers, wind farm operators, and they're saying, hey, wait a minute. Instead of a battery, can we actually put a data center like they're doing down there, in Texas? Because that seems more efficient. And when I see that, I get so excited because in many areas of the world, data centers are just better than batteries, right? They can consume demand at scale. So which means they consume and convert to information right there, electron to information, done on site, right? And compute is necessary for the world that we're trying to build, right? You're delusional if you don't think it is. So, why not you bring that compute to where these kind of imbalances exist and balance the grid at the source, right? And batteries do a great job, but we convert it right there. There's nothing more efficient than just converting it into a highly valuable resource at the source, right? Like,
Which, yeah, that goes back to like the whole history of the power grid, where nobody wanted the power plant right next to them. It makes more sense to put it right there. But then, you look at like, well, Niagara Falls was far away from New York City, so they had to bring it over the wires. But now you're able to bring the demand to where the power is being generated, and that makes all the sense in the world.
Yeah, I mean, huge places that generate lots of wind typically don't have massive population centers, unfortunately, right? And it creates massive imbalances, not just state to state in America, but country to country, because countries can't monetize the wind that they have. Like all of a sudden now they can, and I can't be more excited, right? Like this is all of this AI that people are concerned about how much compute it's using is going to be the catalyst for green energy. Like
That's the ones. And I think, as we go forward, that'll be probably one of the topics, when can that start? When does that transition start to happen? I think probably over the next couple of years, that's going to become a bigger and bigger. AI's already had its little flat, and that, the excitement over it and all that. Now people are figuring out how it really works.
I mean, companies they're collecting the data.
The day,
Make
yeah,
no
it was in the
mistake.
front page
They're
of the Wall
gonna
Street
need to
Journal
mine
today.
it.
It was like,
You know,
it's really
exactly.
expensive. It takes a lot of power. So now it's going to be the fun part, and that's where you guys come in and figuring that part out and supporting what's probably going to be the biggest mega trends since the internet.
And it's gonna usher in green energy. It's gonna be wild. I'm so fired up. It's great. So thanks for having me.
So, well, all right. Well, Dip, thank you so much. Appreciate it. Great to have you on. And thank you so much, everyone. Just a reminder, we will be putting out a follow-up note on this, and the replay is available will be up on the Water Tower Research and probably on the Soluna website in the next day or so. Thanks so much, everyone.